Hello, everybody. We will teach in this course about robotics. We will go from the basics of robotics to robotic software. We will do a small assignment about it, and I hope you learn and enjoy this. So, during the recent times, there have been increase in the robotics domain. You will see a lot of robots, even you are not imagining them as robots, you will find them near you. For example, here, the iRobot. It's a vacuum cleaner, but it's a kind of robot. And these are KUKA robots. KUKA robots are mostly used in industrial. For example, they're helping in making a factory run to make cars. For example, in Germany, Audi use it, Volkswagen use it, BMW use it, and so on. And then we have Franca Amica Panda, which is a very recent robot by the headquarters are in Munich, and they are mostly in terms of human collaborative robot, where a human is interactive with the robot and it acts like a kind of an helper robot. So these robots, which are KUKA, they are done independently doing a specific task. These are more human collaborative, they collaborate, and these are robots which you find they're attaining a specific task in your home. So it's a very wide definition what a robot is, but you understand that. Also, has been recent development also in the personal robot, for example, like Jibo, which will be helpful. It will be like personal companion for you, a teacher for your kids, and so on. There are a lot of examples. In this course, what we are trying to achieve is we want to give you the basics of robotics, how you get started with your imaginary ideas that you want to look at a robot, or you want to use a specific robot that is already available and enhance its functionality. So what we will try to do in this course is we will give you a building blocks, basic building blocks, and keep you learn everything from the basics from the mathematical side to the practical side, so you know how these robots are working, and then in the end you would be able to make your own ideas. Maybe your more imaginative robot that you imagine a robot will look like for you by yourself. We'll go deep into it, we'll make it into it. Okay, let's see what's the course structure is. Okay, the course structure is I have not written down into a very deep level. It's just a broad view level. We'll go deep down into each individual topic. The first one is installation and robot operating system. So since robotics software is a very wide range, it's a huge area that we want to discuss. Basic take it from hardware controllers to object detection to path planning, motion planning, and so on. During this Due to this very wide range of domain, people have started writing an basic standard of libraries that might be useful so that we do not have to reinvent the wheel all the time. And this robot operating system, although it's not an operating system, is a standard library that is being used in robots. You will see in the later in the slides how many robots are actually there are more than 135 robots industrially accepted that uses ROS, and ROS is a set of library that help you get all these robots to visualize it, to start working with it in a fast way. It has a middleware that lets you build all robots in a more um, atomic or modular fashion. Then in the first, we'll just install robotic operating system. We'll go a little bit into it, but we'll go more dive as we start a basic idea, basic example, and then we'll keep on touching each individual parts from each individual uh, area or topics. Okay, then robot controllers. The gazebo is a simulation where you control your robots. You make your robot controller. How does each motion? What does your robot will look like? You have a 3D model out of it, and then you assign these motion. How does it look like? Then comes motion planning. What is a motion planning? Now you have a robot that you built in gazebo. You are put it in a ROS environment, and how do you want to move from point A to point B? Yes, if you want to move point A from point B, you need to know what path a robot should take based on what are its joints, how capable of it from moving from point A to point B. Move it is an open source library that is integrated with ROS so that we do not have to rewrite by ourselves all this inverse kinematics, path planning algorithm. We just need to know how to use it and whichever feels best. Then object detection. We will not training our object detection model. We'll be using all the models that is being available, as the idea of this course is to get you the basic building blocks, how each blocks work, so that you can use your own robots or your own ideas with the robot to make it up and running. Okay, we will use one deep learning model, maybe YOLO, maybe Max RCNN, and then we will have 3D sensors. We will generate from this, you will use the 3D sensor to get the 3D position of a robot, of an object. We will detect this object, we will pick this object and we'll place it as object. This will be your assignment altogether. So in the integration set, we'll in all these topics, we'll be keep hitting this deep inside the robot operating systems and move it and so on. So think of it as an interactive course where you'll be learning the basics of what you need, mathematical and all the plus you'll be doing practical side of it all together, and in the end you will have one assignment that we will use our base assignment, that is when we pick and place an object. We detect an object, we pick it and then we place it, and then you will use your own imagination how you can extend it. Okay, let's see what a base assignment. You have one Franca Pandica Emica robot, you have one cube, then and you have a placer. Then we have a 3D sensor. This 3D sensor detects this and then it tells the robot, from as soon as this 3D sensor, we use object detection here, we detect it, then we tell this robot, okay, the object is here, please pick an object. Once pick up, this pickup uses move it library, motion planning, path planning, and so on. And then it picks up this object. Then again, it uses motion planning, path planning, and then it places these objects. So to to change to change the functionality or the joints detection, also mechanical functionality on it, we will be using Gazebo. ROS is an our system integration. It's like a middleware. It will be our system. Everything will be integrated in the ROS architecture or ROS environment, as you can say. And then we have 3D camera. This is inter real sense camera that will be used for our detection. Don't worry, we will give you the point cloud for your own version so that you do not have to have a 3D sensor at your place. These all will be done in a simulation environment and which we can visualize it in Arvis. It's 3D environment that you visualize it. And as I told you, Move It is a motion planning library that will use to plan all the things and so on. This is with the robot is Franca Panda Amica we will use. For doing this, all you need is enthusiasm about the robots, how you want to learn it, and a Python. That's it. And we will be going step by step, and it will be very easy. And if you feel any question, you can always ask us, and then we will be able to answer it. But I think don't worry about it. You do not need much knowledge. All the knowledge will be given into this course starting. Just hang on, just think a bit, and then you'll be good to go. Okay, let's see. This is not a very deep dive into the robot operating system. It's just so that we just install it on our system. We know what is ROS because everything that we build for our robot, the base is robot operating system. It imagine you have a system that is built around this robot operating system. All will be using this. It's like a operating system, and you are running your robot application within an operating system. Okay, and that's why uh, we will go deep dive into the core concepts of ROS when we will start doing our implementation of our assignment. So let's say first when we start moving it, we will learn what is a ROS node and so on, topics, node, messages, and so on. So just try to give you what is an ROS overview. We'll just touch a bit and we will go deep dive into more in the next slides or next upcoming lectures. Okay. So these are the some of the robots that is being used by ROS. So ROS has a very wide variety of support, very huge support, a huge community, and every year there is a conference held just for ROS people. And as you can see, now Willow Garage, Toyota, the Hoskai, the Kuka robot, everybody they use ROS as an icon, and ROS is being used as an industry base that being used for the robots to come into effect to work on it. So learning ROS is a very good, I would say, good quality of, or it's now the near future, if you look for jobs as a robotic software engineer, it's one of the basic requirement that you need to know. Recently, ROS has launched ROS 2, which is also in experimental phase. For this course, we will stick ourselves with ROS, and that too in Python. ROS is also available in C++ and well. Just for the quick learning so that you understand the basic, we will keep on Python, but we will sure touch ROS and ROS 2 very later into the when you know all the basics and so on. Okay, and so let's see a quick video what ROS has developed over the 10 years. You can see this video and how it's been. So this one is a PAL robotics. Just see, yeah, see this one. This all being done in ROS environment. This is pick and place. This is hand from ETS Zurich. As you can see, there are 3D sensor with deep learning models. There are wide range of its work. So pick and place, detection, so on. How this is always with developing. This is outside robot in the outside environment. This is Magazino. They use this company in Munich. Okay. I will share the link for to if you want to know. I just wanted to tell you or to show you how big the ROS is, how big it's how what are its potential into it, and why we should learn ROS in general. Why not? Because it saves a lot of time. It's one of the base. It's standardized in industry, ROS industry, and it's being widely used in research and also, as you see, in robots that is being used. For example, Magazino develop production ready robots to other people. So yes, you and so let's dive a little bit into the introduction about what ROS is. We will go deep dive as we'll hit the as we'll come close to the actual topic of when we were doing assignments, so yeah, hands-on assignment. So let's just go through the introduction. So ROS is an open source or robot operating systems. As the name suggests, it's an operating system. It's not an operating system. It's a set of software libraries and tools that help you build robot application, and that will work with a wide variety of robotics platform. Okay, it was originally developed in 2007 and over in at Stanford Artificial Intelligence Laboratory, and then development continued at Willow Garage. You will also see a lot of robots being which ROS supports are Willow Garage robots done by Willow Garage. Um, for example, Turtlebot 2, they're very good robots when you want to see them in real life, like hardware that is available to learn and so on. Since 2013, open source robotic foundation was made and ROS is controlled. So they wanted to make a standardized open source of out of it, and so robotics foundation for robotics research and so on, so that they standardize ROS and can ship into production ready. And this is since 2013. It's managed by OSIA. So it has two sides. One is the operating system side that provides, as I told you, hardware abstraction. That means you write your hardware controllers, the controllers, because let's see, you have a robot and you want to move from point A to point B, and then there are controllers that need to be sent information in terms of how much angle it has to move, or how much um, information it needs to move to, for example, how much centimeter it needs to move. So what the ROS provide, it's a high level abstraction of this hardware. You write generalized controllers out of it, and then you can use your underlying hardware. You can change the hardware, but you do not need to change the software controllers to write it. So when you say a robot is using your robotics controller, that means it has a software controller written that can be used. You just need to change the robot controller on the hardware and it will still work. Okay, And then it provides a low-level device control, for example, end effect controllers, where you want to change end stops, you want to customize its what do you call, calibrate it the robot, what you want to customize its minimum and maximum angle in terms of a rotational joint, or which we call in robotics revolute joint. And also it implementation of common use messages for passing between, for example, you have a process that is just used for moving the robot from for the motion of the robot, and then you have a process that is used for camera configuration, for detection. So you need to tell the robot that when the camera detects it needs to move, and these processes need to be talking about it. And this helps, Ross is very helpful. We will see how it is helpful to send the information among these two. Okay, and then you can always write packages, and these packages you just try to write as modular as possible, because if you write as modular, for example, you write a package just for object detection, it's a generalized object detection, and you can use in one project. And then you have another robot, for example, your first robot is for industrial project, and then you detect one object, and then you want to use in a human collaborative environment, you want to use this object detection model, you just take this package, install it there, and use it. That's why ROS is very advantageous in that context. Also, there is a wide variety of research that is being done in SLAM, that is simultaneous localization and mapping, planning, perception, vision, manipulation, that the user, the people that the research, big universities, big research institute are researching into it. They make packages and they provide it as an open source, which we can, as you, as a learner or as a company, can use it to develop their use, so that they do not have to reinvent the wheel or reinvent the algorithm which other universities. This is why it's very great. You have a wide variety of research, you have up-to-date research, up-to-date algorithms available for you. All you need to know is ROS and how to use them. So, and then this helps you, and this reduces a lot of effort and time to get your robot to the market. Now we will see what are the ROS main features. As I told you, there is communication, there is visualization, how you view in 3D. You do not have to develop your own OpenGL visualizer. Perception, you have a perception stack, which you can put your own sensor, and then it will work out of the robot control. That high level control, hardware drivers, machine learning, it's been new in the ROS. It's not been so widely used as of now, but we can always take a look. Data logging, it's very important, because you need to know where did your robot face an error, and this is very important. Simulation, as I told you, Gazebo does a simulation for how, what physics with physics, what could be done, what can happen. Computer vision, and the computer vision and perception is a little bit more related to each other, and you can also link computer vision with machine learning and perception. But computer vision here means calibration of cameras. Basically, if you have multiple cameras, how you calibrate these cameras. And we will also see, we might not do a example out of it, but we will surely touch this topic. So we will touch each and every feature out of it, but not only, just not on the technical. We will be reading this stuff. We will be doing one assignment of our Franker robot, and we will be seeing on the go where happens what, and that's why you can learn faster. Okay. Then we have ROS components. Just do not worry about this at the moment. We'll touch each and every topic in the next lecture. It's just a ROS master. This is one master that has a ROS should be, where everybody should talk around. Then there is nodes, that each independent nodes, one its nodes. It's a publisher subscriber models. So you have nodes, your end processes where processes are run. Nodes, services, and actions are different. But if you want to just see them all together, just imagine them, they are services, but there are three different kind of services or processes that are running on these services or types of. Just think about it as of now, but you will surely understand more what's the difference and ways to use what. And topics is just like, you want to send a mess, you want to, so let's say you have a robot and it has a velocity parameter, it's moving with some, and yes, you want to say I have a robot A, I have a robot B, and Then we create a topic of robot A and velocity topic and robot B and velocity topic. Then you have two different topics, and one of my nodes or the row's nodes will try to processes need this velocity to estimate where it will be the next position or what it should do, and then so does it. So what we can do, we can subscribe to these topics and get all the information. If you want to subscribe to robot 1, then we can subscribe to robot 1 or robot A velocity, and similarly if you want to subscribe with robot B velocity, and then we get information of these two um, robots with these topics. So information are published on the topics, and then you subscribe it. And then packages, as you all see, we can create one small package. What you want to keep in a package depends on you, how you want to do it. But try to keep it as modular. Think of it packages as a software package at what you want to keep it, what where you define that this would be my package, and then try to think of it. If I want to use this package and if I want to use another project, will this be a package? Yes, then please make that as a package, and just think of it. You're not making one robot, you're making a packages for the robot that you want to use later. Okay, and parameters and so on. So we will go deep dive into it next. In the next lecture, we will start with the installation of the this ROS, and we will just try and hands on for the first try.